Welcome to Sairam Triple YouTube channel. Let us discuss module 1 of high voltage engineering subject. Subject code is 18 E56, right? So let's start with the module. So what are the topics we are going to discuss? Gases as a insulating media. So everybody knows, right? Gases are the insulating medias. Collision process, ionization process. So collision between two ions or two electrons, and then also ionization process, movement of ions, and then so bombarding of two molecules, or that's also we're going to discuss now. And thousands current growth equation. Thousands is a scientist name. So one evocation we are going to derive. Current growth in the presence of secondary process, thousands. Criteria for breakdown and experimental determination of coefficient alpha and gamma. Breakdown in electronegative gases. So even though electropositive gases will be there, negative gas will be there. Okay, time lag for breakdown, streamer theory of breakdown in gases, and Passion's law. And also we're going to discuss breakdown in non-uniform fields and corona discharges. So everybody knows, right? Corona, like hissing noise, violet glow, formation of in the surrounding of conductor. So conduction and breakdown in liquid electrics, liquid as an insulator, pure liquid and commercial liquids, conductors and breakdown in pure liquids, conduction and breakdown in commercial liquids also will be there. And breakdown in solid electrics, introduction part of solid electrics, and intrinsic breakdown, electromechanical breakdown, and thermal breakdown, right? So introduction part of the module. Dielectric materials is a poor conductor of electricity. Everybody knows, right? So here is a dielectric media, and wood is also a dielectric media. So it's a poor conductor. And what are the good conductors? That is copper and then metals. Okay, so good conductors. Here the dielectrics are poor conductors of electricity, but it can be conducted by applying the high electric field. Okay, so if you pass electric field to the dielectric media, if suppose air would be there, so there is a conduction between one rod to another rod, or so spark will occur. Or if suppose if you heats up the wood, what happens? It will conduct, right? And it will sometimes it will heats up, in the sense it's a conduction, or something will be happening. It is an efficient supporter of electric field. So electric field is must, right? If you can, if you transfer electricity, or if you excite another metal in between, there is a air present, so that is also needed. Whenever we are applying electric field, the position of ions get changed and support for electricity conduction. Fifth one, examples of electric materials are mica, glass, or and ceramics. Everybody knows, right? So already we discussed class YAEB uh, insulating materials. In that we have a mica, glass, and ceramics. Dielectric strength. So we need to know the strength of the oil or gas, or any of the materials, right? So the electric strength of an insulating material is defined as the maximum dielectric stress with the materials can stand, right? So factor affecting the dielectric strength, or pressure must be there, and temperature, and humidity, the nature of the applied voltage, imperfection of materials also. So types of dielectrics next. So gas or vacuum dielectrics. So gas is a dielectric media, everybody knows. SF6 gas is a dielectric media, and liquid electrics, oil is a liquid electric, solid is a wood or whatever you consider, plastic also solid electrics. Composite dielectrics, so composite materials we are having, so PVC pipe or whatever. So these are the dielectric materials. Okay. Mm, Gas or vacuum dielectrics. First one, it has high dielectric strength, 10 to 7 voltage per centimeter. Breakdown occurs in the gas or vacuum is due to collisional process, ionization by collision. If the applied voltage is sufficiently large, electrons are multiplied in an exponential manner, breakdown will be occurred. Example, sulfur hexafluoride, SF6, and CO2. Liquid dielectrics. The liquid dielectrics are used in a high voltage equipments for a dual purpose of insulating heat dissipation. Temporary failure can be quickly re-insulated by the liquid flow to the affected area. So a temporary failure will also occur, right, quickly. I mean, re-insulation is needed, right? If suppose like spark occurs in the insulator, what happens after some time, and again it will be like uh, re mode. I mean, mode will be, if suppose fault occurs one mode and the fault occurs again, it will come to same position. So re-insulated by the liquid flow to the affected area. Highly purified as liquid is more suitable to serve as a dielectric media, and dielectric strength is up to 1 megavolts per centimeter. So 1 megavolts per centimeter. Breakdown strength reduces due to impurities. Mm. So if suppose oil contains water molecules or any dust particles or any other particles, what happens? The strength of the breakdown strength is reduced, right? Selection of liquid electrodes is based on the electric strength, viscosity, stability, flash point. So these are all the characteristics. Okay, selection of liquid. How do you select liquid dielectrics? In the sense, we need to say dielectric strength, viscosity, stability, and flash point, and gas constant. Examples of petroleum, transformer oil. Even though where exactly we are using, I mean, transformer oil in the transformer. I mean, for what we are using transformer oil? Because of insulation purpose, right? If suppose supply is given to the primary side, induces EMF in the secondary side according to mutual flux linkage. If suppose current passes through the winding, what happens? It produces heat, right? So to avoiding that, I mean, like heating up the overall transformer, we have a cooling device. I mean, cooling oil inside transformer for insulating also. Because electrically it's separated, mechanically I mean magnetically it is coupled. So that's why the transformer oil we are using there, and also petroleum we are using. Application area where equipment is continuously operated, like a distribution transformer, right? So even in the distribution transformer we are using. Next is a solid dielectrics. It has a good mechanical strength, bonding capabilities. A dielectric strength 10 megavolts per centimeter, means solid dielectrics. I mean, electrical apparatus like pin insulator will be there, a shackle type insulator, ring type insulators will be there, and the power stations, power plants, and all. Those are applications. Example: inorganic materials, ceramics, glass, organic materials, PVC, polyethylene, natural rubber. These are the solid dielectrics. It is needed, right? So, if there is a cutting plier, will be there, or any electrical repairing device, maintenance devices, or tools we are using while repairing or whatever. So that time we are using like insulators for holding that equipment. So that's a solid dielectrics. Keep it in your mind. Okay. So in that the dielectrics are like um, operated as a like both in like insulator or it's like a dielectric materials. Ceramic, see ceramic where exactly we are using in the insulator part, right? So you can see in the overhead transmission lines there is a brown color insulators are present. Even the glass insulators also we are using in the uh, power transmission purpose, instead of using ceramic ceramic insulators we are using nowadays. Glass is a high advantage, I mean more advantage will be there. And organic materials, PVC, polythene, natural. Application of electrical apparatus, they are using the solid dielectric we are using there. Composite dielectrics, combination of more than two kinds of insulators. I mean, it's a composite. I mean, adding of, I mean, combination of two kinds of insulators. Chemically stable, long life span. Composite dielectrics is a long lifespan because it's two kinds of insulators we are adding. Why we are adding these two? I mean, whatever two insulators, because to improve, to increase the efficiency, to increasing the lifespan. So that's why we are adding instead of keeping one. So we are adding two. But dielectric constant, two materials should match. Two insulators never react together, so it should not be react together. Okay. Examples: oil impregnated paper, oil impregnated metalized plastic film. So These are the examples we are choosing. Just keep it in your mind. Okay.